All right, guys. So I did our notes on the board the other day. So I'm going to go ahead and just write us out some notes over factoring day 4. So on day 4, it was all about difference of squares. And perfect square trinomials. All right, so let's start our attention by talking about just difference of squares. So in class, we talked about a difference of squares is when you have a perfect square, so like a squared, minus another perfect squared. Oops, I'm so sorry about that. B squared, okay? And what ends up happening is it ends up factoring into a minus b, a plus b. So we did a couple of examples in class. So if I have x squared minus 25, well, the square root of x squared is x, and the square root of 25 is 5. So this is going to factor into x plus 5, x minus 5. It could get a little more complicated. You could have like 64x squared minus 144. Well, the square root of 64x squared is 8x. And when we talk about square roots, we're talking about what can I square to get 64. So what square gives me 64? 8x. What square gives me 144? 12. So this factors into 8x minus 12, 8x plus 12. And like which one goes first, like the plus or the minus, that doesn't make a difference. It's whichever one you want. Okay, so that's difference of squares. Perfect square trinomials are kind of fancy trinomials. And give me a second. So remember, a trinomial has 3 terms in it. So my first term is a perfect square, my last term is a perfect square, and the term in the middle is 2 times a times b. Now, it could be plus 2 times a times b, or it could be a squared minus 2 times a times b. If it's a plus, you're going to find the root of the first one, the root of the last one, and it's going to be a and b quantity squared, so we're going to square that. And because this is a plus, we put a plus here, so it factors into a plus b squared. This one factors very similarly, and then it's a and b squared, except for this time because it's negative, we put a negative there. And it's just a little shortcut, okay? And on these, you can still do AC method if you'd rather do AC method. That's perfectly acceptable. The only thing is your numbers might be really large, okay? So let's look at some examples. So if I ask you to factor like 64x squared plus 80x plus 25. You'd be looking at that saying, oh my God, I got to take 64 times 25, which is 1,600. I got to find things that multiply to 80. That can get really, really complicated. But if you notice right off the bat that 64 is a perfect square and 25 is a perfect square, then it's probably a perfect square trinomial. So the square root of 64x squared is an 8x. The square root of 25 is a 5. And if we notice in the middle, this should be 8 times 5 times 2, which is that 2ab part, which is true. 8 times 5 is 40, and 40 times 2 is 80. So this makes this a perfect square trinomial, which I write as PST. So the rule says it's going to factor into a plus b squared, and I know it's a plus because that's a plus. So my a term is an 8x, my b term is a 5. I put my plus in the middle, and then I square it, and that's it. That's all you're doing. Now, you have to know the rule, so that's kind of the complicated part of it, but once you realize the rule, it's not so bad. Okay, we're going to do another one. Let's do 144x squared plus 72x plus 9. Again, on this, you're looking at this, you're thinking to yourself, I got to take 144 times 9. That's 1,296. That's a big number. And I don't really want to do that if I have to do AC method. So this is when you might want to say to yourself, is this a perfect square trinomial? And since I'm doing perfect square trinomial examples, you would answer yourself, yes, it is, okay? So if you notice that the first term is a perfect square, it's a 12, so 12x. And the last term is a perfect square 3. And if you check the middle, 12 times 3 times 2, well, sure enough, that's 72. This will factor into a plus b squared. So my a term is 12x, my b term is 3. Put a plus sign in the middle, and I square it. And that is a perfect square trinomial rule. There was one thing I forgot to talk about when I went over here in difference of squares. Difference of squares only works if there's a subtraction sign in the middle. So if these said x squared plus 25, that does not work. We call those prime because you cannot find two things that multiply to 25 but add to 0, because essentially x squared plus 25 is the same thing as x squared plus 0x plus 25. So if I was using goal numbers, I'd want two things that multiply to 25 but add to 0, and I can't do that. I can't find a pair that'll do that. So that's why they're prime. So if they have a plus sign in the middle of them, you cannot use the difference of squares, okay? So make sure you know how to do that. So make sure you pick up the worksheet in class if you didn't. And I wrote factoring day, and then I didn't write anything after that. This was day 4 of factoring.